Today is the test. It will be through the material we get finished with today. Okay. Yep. Okay. You hand in what you've done and show me that you have tried. Okay? Then, if I didn't like what I got and gave you a 50, then you, when you get it back, you redo it and hand it back into me. And the reason for this, a number of people are not doing their homework and they're asking it in class, copying it down. Okay, so here we go.
Hey,
Okay, thank you. This quote I'd like to give you. We're going to do the mean value theorem today. And a guy by the name of Larson writes this book. And he says this about the theorem. Although the mean value theorem can be used directly in problem solving, it is more often used to prove other theorems. In fact, some people consider this to be the most important theorem in calculus. Okay? And to that, I wanted to just give you an idea of the importance of the mean value theorem. Okay? Now, before we go into it, what is it all about? I want you to go back to page 225. 225. And look at the extreme value theorem. So, Brianna, what does the mean value, the extreme value theorem say?
Did you guys mean?
Yes, I did.
The extreme value?
Yes. What does the extrema or the extreme value theorem say?
Is that like the...
I just told you what page to be on.
I got it.
Okay, what is it?
It is a function that is continuous on a closed interval AB has an absolute maximum value and an absolute minimum value on that interval.
Okay, thank you. Now, what interval are we talking about here?
AB?
And what is it, an open interval or closed? And what do we have on that interval? Always.
Math.
Okay, now would you look over to the left, and it says this: the proof of the extreme value theorem relies on some deep properties of real numbers found in advanced books, of which this is not one of them.
This is not an advanced book? That's multi.
Not a number theorem. Okay, so.
That's children's play.
Thank you, Grant.
Mr. Kramer,
We know
that's the
better.
sixth grade.
Okay. Hey, see the theorem? Now, we're going to go to another theorem on the next page. Chanel's going to read that one too for us. That's 4.2 at the bottom there. And what does that say? Page 226.
If f has a local minimum or maximum value at c, and f prime of c exists, then f prime of c is equal to 0.
Oh. Now, if I have f prime equal to 0, is that a critical number? No,
No.
it's not. See, that's that necessary and sufficient stuff we were talking about. So, it says if we have a max in or a min, we're going to have a 0 for our first derivative. Okay? Now, so those two are going to come into play today in terms of what we want to do. Now, we're going to prove a theorem and see how it works. The first one we're going to do is go to page 46. 276. 275. 4.8. Gotcha, thank you. Oh, good. Okay, see that says there, Rolle's theorem? Now, we need to have that theorem to prove the next one. This is a kind of an easy one. And here it is. It's like this. Chanel, will you read Rolle's theorem for me 2 minutes, please?
The whole thing? Oh, not mine. Okay. Let f be continuous on a closed interval AB and differentiable on AB with f of A is equal to f of B, there is at least one point C in AB such that f prime of C is equal to 0.
Okay, a whole bunch of stuff. Differentiable, continuous, and what does it say, Chanel, in terms of these 2 points?
That is differentiable.
Yeah, it says that. And does it say anything about an what f of A is? By the way, this point right over here, this is my function, and this point here is A comma f of A.
F of A is equal to f of B.
Got that? Very important that now we have this point over here, which is f of B, and we're saying this is true. Okay, so what? What does that give us? What is true about this line right here, this green line?
It's a constant.
It's a constant.
It's
What
parallel.
is the slope of that line?
0.
Got it? The slope is 0, and now,
Parallel to the orange line.
and that's what we're going to see. And the parallel to the orange line is not the big factor. The big factor is this one has the same slope as this one.
So it's the same
Yeah, yes. And like in this case, we're going to see that f prime at any point in between here, which we don't know, at some c point here is going to be equal to 0 here. And that's the same thing as going to be up here. Okay? Now let's go and prove that thing. Maybe I'll just do it up here. I'll write it up here. We're going to prove this little thing. And we got 2 steps. The first one is this. In terms of it, you see, we know that f at A equals f at B. See that? Okay, now, the first thing we're going to say is that the extrema, or the extreme values, happen at the endpoints.
It's just fine. Settle down.
Are you with me? At the endpoint, we're going to have the extrema.
Not gonna get enough.
Tanner?
Is this the proof of Rolle's theorem?
Yes, right. This is Rolle's theorem. Okay, now, if the extrema happens at the endpoints, what's happened about all the way in between?
No, it's just nothing.
It's the same. Every point is the same height, and so, and what happens at an extrema? That 4 point, the second one that Chanel read?
Absolute max and min.
Pardon?
Major max.
It equals 0.
Then it's going to be an absolute or a minimum a max, yes?
The derivative is going to equal to 0.
Did you hear that?
Yeah.
The derivative is equal to 0. Okay? And then in terms of what Grant said, it's true all the points, so we're done. Not only is there one point, every point is 0. Boringly so, it's just a straight line. And De Vries said something about a constant function. So all those ideas are working well together. So we got that done. Now, here's the second one. The second part of that thing is this. This is not the extrema, and that is not the extrema. Okay? In other words, it is not the maximum value. Okay? And if this one isn't, then that one isn't either. Because they're equal. Okay? So, therefore, it is continuous from here to here. And in that situation then, what do we know about in between? There has to be one point at least. It's going to take on a maximum or minimum point in between. And that's going to be equal to 0. Okay? Questions on that?
No. That's a proof.
Yeah, that's a proof.
Oh,
Okay. Because the second part says the extremes are not happening at the endpoints. Now, probably this isn't the best drawing. Maybe I can do another one. I'll just try to think about that a minute. Let's see here. Here we go across this way. And how about a new f function? We'll make it a round one. And I'm going to go like this. Oh, that's good, Kramer. Oh, great. See that? See what happens there?
Oh, wow.
Now, look what happened. This is not an extrema, and that's not the extrema. Right?
Right.
So it's not that. So it's going to happen in between. And in fact, it happens here, and it happens down here. There are two of them. Yes.
How do we use this for problems-wise? How do we use that?
Oh, hang on. We'll be into the police department by tomorrow with it.
What? Do we seriously do
So we're
that?
gonna be doing.
Okay.
How fast can your
This-
front dog take it
this-
right now?
Guys. This book uses it. When I was going to school, I remember one of these things coming up when I was going to grad school in Chicago. We used it. We'll have a few ways, but we're not going to use this one. We're going to use this one. But we'll get there in a moment. Now, hey, this is, I think, pretty cool. This brown one. See that? Now, remember, Chanel's pulling a face because she's wondering about it, I think.
No, I just can't see.
Oh, okay. Now, in this case, remember the second one she read? It says, is this thing continuous? Yeah, just as nice as can be. Differentiable all over? No problem. And now, it says there's going to be a max and a min in this interval. Here's a max, here's a min. And if you have a max or a min, you have f prime equal to 0.
Oh.
Okay? Questions? Now that's the first one. Now we're going to do the big one right here. That's this one. Now look what happens here. Chanel,
Yeah.
you're doing such a good job of that. Will you read the mean value theorem, please?
I'm not sure what that is.
It's the next page.
I found it. If f is continuous on the closed interval AB and differentiable on the open interval AB, then there is at least one point C in AB such that f of B minus f of A all over B minus A is equal to f prime C.
Yes, okay. Now, yes.
Are we gonna prove using a test for this?
Oh, yes, the next one.
Or are you gonna
Like next week?
Yeah,
So are you gonna give us the proofs?
we'll see.
Oh, no.
You come along, you'll see this thing develop in just a few minutes. Yes,
So how do we prove rolls?
I just did.
But how?
Okay,
You just
okay.
won't be that
Talk to crew.
Listen. Jeff has got trouble, and all of a sudden he knows why, and then he's not satisfied. So, here we go. We're going to redo Rolle's theorem.
Alright.
And I won't ask you this one on the test.
Oh.
Although I will ask you on the test that you're going to use Rolle's theorem.
Oh.
You've got to use it to prove the next one. Okay, Rolle's theorem says, if your extrema are happening over here, you got the green line.
Okay.
Because you can't go up and down, you've got them both. Minimum max,
Is
yeah.
that saying your min and max are the same value though?
Yes, right.
Okay.
Yeah.
Whoa.
Nice, good observation.
Oh,
Okay?
okay.
Then the second one
Yeah.
is, you got that?
I get that.
Okay, now we're ready for the next one.
Can you?
Okay, here we go. Yeah.
But to prove the Rolle's theorem, all you need is that graph, or do you have to explain it?
Explain it with those two steps.
What two
Can you write those out?
Okay, okay, at this point, quick talk, waving hands, talk loud, that does it. You're not going to do that for me. I'm not going to ask you to do it. If you want to read more details, it's in the book too.
Okay.
Okay? Now, if you want more, Brianna?
No.
Okay,
If I don't
because
need to prove it.
like Jeff wanted more, so I gave that to you once again. So you know that this one is the case. And, okay, now, we're gonna go over here. What we're doing is seeing that this brown line is parallel to this orange line, yes,
And this one we have to prove on the test?
yes, yes. Okay. Now, here we go. The diagram is helpful, it's mean value theorem. you notice that this point here is A, F of A, and this is B, F of B. So things are a little bit helpful in a moment. What's the slope of this brown line? Or this orange line for that matter, but let's just go to the slope of the brown line. What's that slope? By definition, way back.
F of B minus F of A over B minus A.
Okay, and did you see that written in the book?
No.
You
It's
should
the
have.
derivative of.
Oh.
Okay, you see this? Okay? Now, just a few more little things in terms of detail here. I'm getting a little bit too much stuff. That's going to be here. Now there's going to be a point right over here. Bingo like this. Right over here. That's going to be point C. In this open interval, or closed interval, from A to B. There's a point in between your C. And it says here, I think in the theorem, it says F prime C equals this. See that? Chanel read that. That's the last statement in the terms of the conclusion. Okay?
Is that the point tangent, or is that the one point where the orange line is touching?
Yes, it is. Yeah, where it's touching here, C. There could be more places in between, but there's going to be at least one. Okay? Okay, so we got that. So here we go. This is how that works. It's kind of clever. We're going to, I need to write something else up there. This function over here, this is going to be my L. See that? That's line L. Are you with me? I'll be over here now. I'm going to make a new function. Okay? You'll need this. And my new function is going to be g at x, which is going to be equal to f at x minus L at x. Now, I don't know if you can see what function that is yet. We've done some of these before. It's this function minus this function. And if you have that, you're going to find this. G at A equals F at A minus L at A. And what is this equal to? We got it right here. He says this is equal to 0. Are you with me? That's probably the hardest part of the whole business, I think. Okay?
It's equal to 0.
Okay, now, do that again. Notice these two, my two functions are touching here. So the difference between the two is equal to 0. See, here's my f function here, and my L function is going to be here too. Oh, excuse me. This is L. I'm sorry about that, guys. This is function L. Okay?
Look, that brown line is?
Yeah, the brown line is L. The brown line is L.
And that's also F prime C, you said, right?
No.
Well, then what's the error to?
We'll go there. We'll get there. It's going to thick us a little bit.
Is the orange one G?
No. Just a second. What you're going to get with your, I've got this one. My G one is going to look like this.
All right.
Is it because the F is a third degree?
This is going to be a G, something like that. Okay. Now, come with me.
Mr. Kramer?
Yep.
So like the f of b minus f of a over b over a, that's the slope, correct?
Yes. Okay. Okay. So the main thing right now is I'm making my G function to do some things for me. Just for a little thing here, I think this is a nice little extra part. F of b minus L at b is equal to what?
0.
Are you totally convinced?
No.
Yeah.
No.
It's the same thing as A, just.
Yeah, just on the other side.
Yeah, but I still don't understand why it's 0.
Okay. Here we go. To help you. We're just going to say this function, this is going to be a number. Okay? And shall we just make that a 10? We'll say f of b equals 10. Okay? And how far is this brown line up? 10. And then so L of b is also 10. And what's 10 minus 10?
Zero, gotcha.
Got it? And the same thing goes over here. So we're making a new function, and it's gonna look more like this orange line now. Because this point is gonna be brought down here, and this one's gonna be brought down here. Okay? Now, with that in mind, I have Rolle's theorem. I'm gonna use Rolle's theorem next. Okay? Because at this point, I know G at A is equal to G at B, right?
Oh, yeah, yeah.
Which they both have to be equal to 0, but this isn't the big deal. They don't have to be 0, but they are. Yes?
How is that possible if they're both 0, but G on your graph over there it's only has one max from what you drew?
On the graph.
On the graph, it has one max.
Yeah.
It could have many, but we have one. Now, what we're going to find, okay, just a second.
But then the slope of G and A and G and B would be 0.
All of that.
Max is
Are you engaged with our discussion over here? With Trevor?
Kind of.
Okay?
No.
Trevor, I'm puzzled.
Like at A and at B on your graph of G,
Okay,
the slope
here.
isn't 0 there.
Pardon?
The slope, it doesn't look like the slope is 0 there.
It isn't there. Its value is 0.
Oh, okay.
Okay? G at A, not G prime.
Oh,
Okay?
Oh.
So
Oh.
is the little curve
right.
on the roll there, the curve is the derivative?
No, we don't have we haven't talked to
No,
derivative
on
yet.
like the other graph that never mind.
Okay. Okay, now you see this.
Yeah.
Okay, now Rolle's theorem says what? On this interval, what do we have? And we're going to have a max or a min or a critical number at where?
Zero?
C. Okay, so we have one at C. We know that. All functions that are continuous differentiable have that. Okay? So we know at this point that G prime at C is going to be equal to what? 0. Okay.
On.
So the slope is going to be 0 at C.
Okay, now,
Oh,
yes. And that's going to be right down here. Okay, and now what we have to see is that this point is the same one that's up here, although it's not 0 here, it's this. Yes.
What's the label of the brown line?
The label of the brown line, that's
Well,
L.
then what's the orange line? Is that not
That is parallel to that line.
So we haven't used that one.
Not yet. Okay? Now, let's take a look at this. What is G at C is equal to F at C minus F at, oh, this is an L at C, correct?
Yep.
Yeah.
You've asked a lot of questions and it should fall into place real nicely. I'm taking the derivative of all this. This is going to be, the derivative of this is G prime like this, correct?
Yep.
And then this is going to be, we have a theorem way back that says we can do this. And so are you content with me at this?
Sure.
Okay, that's nice. What is this equal to?
0.
0.
Oh, that's equal to 0.
Uh-huh.
So this must be equal to 0. So we know that F prime at C equals L prime at C. That's the another big statement to do. Are you with me?
Mm-hmm.
Okay. Now I have it on the board, but I would like to know this. What does this L prime at C mean technically? It's a derivative. Okay, Jeff said it's a slope. What's the slope of this line? F of B minus F at A all over B minus A, where we started from. When we got way back here in terms of defining this thing. Is this what we were trying to prove?
Yeah.
There it is.
Well, that was nifty.
Isn't that nifty? Okay? We might want to take another look at it next week, Tuesday, or maybe tomorrow morning if somebody wants to look at it. But that's basically it. Now look what it says in terms of that theorem of 4.9. If f is a continuous function on the closed interval and differentiable on the open interval. Notice that? Why isn't it differentiable on the closed interval? You know the answer. It's pretty important here. Okay? Watch what it says in the book. We're playing with extreme power. Okay? And so it says it's continuous on the open and differentiable on the open. It's continuous on the closed. And if I would write this on a test, I could leave out a few words and let you put in closed, open, and that kind of stuff.
What are you
Okay.
talking about? For what one?
Theorem.
This theorem. Why don't we have a differentiable on this interval? Why not differentiable on that interval? Because often it isn't differentiable on the end because it has an endpoint and we don't know what's happening before it. So we don't have differentiable here.
Because there's,
We don't use the endpoint. Okay?
So it's not possible for a function over closed interval.
Yes, exactly. Okay, now. Now we're going to use these things. Okay? And let's go and use them. And here we go. You probably will never have another class in mathematics like this one, where you get so many questions. I mean the content of students. Okay? You are really blessed, where you get so many questions along the line. It isn't unusual for me to give you this whole thing without a question, if I'm on a college campus. And this is much more fun. Oh, yeah.
How do you use it now?
Okay, here we go.
Problem.
Rolle's theorem first. And it's a little bit different algebra. Okay, here we go. I'll try to get these two finished. And then we can see the use. I do have the assignment up there. Okay, here's my function. Is this an odd or an even function?
Even.
Why?
No, yes.
because it's up and up.
It's up and up and
Because they're all even numbers.
and they're all even numbers. And exactly, really, we're talking about this and this.
Okay.
Okay? Now, I'm going to use Rolle's theorem to find what I'm doing here. And since it's an even function, I need for Rolle's theorem to have a point here and over here that's the same height. That's pretty easy to do. And so I could almost use any number, but I want to be out here enough beyond these 2 points. So I'm going to try the interval -2 to 2. Now, if I go to put a 2 in here, what comes out?
8.
8. And I put a -2, and it better be an 8 also. Oh, -2. -2 here, and I get an 8 up here. Okay, so there's my interval. Any questions? Yes?
So you know you can use it when you have 2 points then? So if you graph it and it doesn't have 2 points that are across like that, you can't?
Not for rolls.
Okay.
But hey, we're only going to be using rolls once or twice, and then we aren't worried about it again.
Okay.
We're at the mean value theorem that we want. Okay, now, a bunch of things happening here. I want to find this point, and this point, basically, okay? And what I need to do now to show that Rolle's theorem holds is I need to find, see, this is, the slope of that is 0, right? And so I need to find another one here, another one here, another one here. I only need one, because it says there's one that exists. Doesn't tell you how many. It's pretty weak that way, okay? But it tells you one, which makes it very strong. And so f prime at x is equal to what? What's the derivative of this?
4x cubed minus 4x.
Which gives me 4x times x squared minus 1. And that gives me 4x times x minus 1 and x plus 1. Okay? So my critical numbers are,
0, 1,
okay? So I found 3 of them.
Why'd you have to do the beginning part then?
What would
Yeah, that,
that?
yeah.
Well, I needed to find an interval where the right side was equal to the left side.
Oh.
Could
And
you-
I chose an even function to make it go easy. Now, I could have also just factored this thing,
Yeah.
and then I would have had probably square root of 2 or something like that over here. Some other problems are gonna go this way. You're gonna have to find the zeros and we'll do the thing down here. Let me do a different color. I don't want to. I could, there's a lot of good stuff, but I better quit at this point because I wanna get another one finished. There's one other thing. What I'd like to do here, I'd like to do the second derivative test. Is this point going to be the max? It looks like it. Okay, so I'm going to take the second derivative. And the second derivative of x is equal to what? That's this thing right here.
12x squared.
12x squared minus 4. Okay, when I put a 0 in here, I get,
-4.
and negatives would make me unhappy, and therefore
Maximum.
it's a max. Okay?
And then are the men.
And then I put a 1 in here, and I get a positive. So it's down here. I put a -1 and I get a positive here. Okay, now, let's go to this next one. The mean value theorem.
So we want the min when we're doing these?
You just want critical points.
We just want a place where the slope is 0. That's all we want.
Okay.
Only a place where the slope is 0 when you have the endpoints that are equal. Rolle's theorem.
So you could have more than one?
Oh, yeah,
Okay.
you have a dozen. In fact, you'd have an infinite number, which is the first one we did. The endpoints are this way, so it was a straight line. So we had an infinite number. Okay, now, let's do this function. F of x equals 5 minus 4 over x. And since I only have about 5 minutes, I'm going to just give you a quick sketch. I was going to spend a little more time in terms of what this graph looks like. And it looks something like this. Okay? Now, and I'm going to do it for an interval from 1 to 4. Okay? That thing is continuous. It's differentiable. Okay?
But we're doing it
So,
on the closed.
pardon?
But we're doing it on the closed circuit, so we just need.
Okay, this point is 1. This point over here is 4. And what's the value here?
1.
1.
Okay, so this is 1, 1.
And then
Then what's this one?
4.
4.
4, 4.
Whoa.
Are you with me? I chose one that would really work fast.
That's crazy.
Okay? They don't all work this way.
Oh.
Only this nice one here. Okay, now, what am I trying to find? I'm trying to find a C here that this slope and this slope are the same. Okay? What is the slope of this line? F
1.
prime at C
1.
equals 1.
What? Oh.
Yeah.
It's equal to 4 minus 1 over 4 minus 1.
1.
Okay? So, there's 1. Now, I've got to find this thing. So here we go. This is how this thing is working, which you were asking a while ago. F prime at x is going to be equal to what? What's this number?
4 over x squared.
Got that? Now, what does this have to equal?
Would it be a -4?
No, because it's a negative. It'd be
Yeah.
-4 over x squared.
Negative 4x to the negative 1 over here.
Oh, okay, yeah.
Okay, got it? Okay, now what does this have to equal? And everybody said?
1.
Good,
1.
thank you. Because this slope and this slope have to be the same. Are you with me? While ago we were doing zeros, now we're doing ones, or whatever this slope happens to be. Okay, now we solve this equation like this. Equals 4. So x equals
2.
2. It also could equal a -2, that'd be over here, but it's outside of our domain.
Do you do it again and make it equal to 4 now or not? Or how come you chose 1?
C is equal to 2 then, right?
What?
Okay, this is 1 over 1. Streams and means. Okay? And so this is a plus or minus. There happens to be one over here for another interval, but that's one we wanted over here.
So
Yes?
does that mean C is equal to 2 then?
C equals 2.
So how come you didn't do it equal to 4? How come you chose to do it equal to 1?
Well, because 1 is the slope.
Oh, that's why. Okay, okay. So I had nothing to do with the interval.
What
No.
does C mean?
What does C mean? That at 2 over here, at 2, the slope of that curve is 1, there's 1. The slope of that's 1.
So the tangent line and the slope in the interval between the points is the same.
Yes. Yes.
No,
Do we have any of the mean value on our, is our assignment just the rolls or is it both?
Both. Both. Did anybody